in this video, we're going to actually continue on with creating the custom stud type. So in the last video, we covered stuff like modeling the actual studs, laying out our reference planes, doing basic parameters for the web, the flange, and also giving it a material type and also creating some types. So from here, we're actually going to create some shared parameters so that way we can actually calculate these and schedule these. We're also going to change its category type so that way it can be a stud material, sorry, a structural material versus just a generic model. And then we're also going to try and touch on the fine and medium detailing. So what we're going to start with is changing the actual category of this stud. So if you go up to this box up here, that actually opens a family category and parameters. So you can see that what's highlighted right now is a generic model. Now, we obviously don't want that. We want it to show up as structural framing probably, unless you want it to be labeled something else, but we're going to go with structural framing. So you can see that it's actually changed the family parameters a little bit. So we're just going to hit OK because these will change over here in the actual properties. There's two changes we need to make here. So in order to have this stud to be able to be drawn horizontally as well as vertically, we have to uncheck this box here, always vertical. And we also need to check the box work plane based. So what this means is when you actually go to place the element, it's going to give you the option to either place on face or it's going to give you the option to place on a work plane. And in this case, we actually want it to place on the work plane. Whether the work plane is a vertical work plane, horizontal, whether it's a level, whether it's, you know, a grid. So that's the main change that we need to do here. This also helps when filtering items as well. So if you're doing like view filters or you're playing with visibility graphics in your project, you wanted to, let's say, filter out all items except structural members and you wanted these to show up, this would be how you would do it. Okay, so that was an easy change. So the next thing we're going to go over is shared parameters. Now, if you never used shared parameters before, this can be kind of complicated. But basically what you're trying to do is you're trying to create a folder of parameters that can be used by other elements or other Revit families as well as projects. So think of it as like a basket of parameters that you can choose from that all families and projects can see as the same language. I know it's kind of complicated to understand if you've never used it before, but I'll kind of go through that with you and you can see what I mean. So we're going to create a new parameter at the bottom here from the family types. And we're going to click shared parameter. Now it grays out a lot of stuff, and that's because we're using a standard, or what we are creating is a standard for across Revit or our Revit platform. So we're going to click shared parameter and then we're going to go select. So in this case, we're actually going to create our own shared parameter file because we have all these, you know, random things that we don't actually need at this point. So we're going to go to create. We're going to call this, I'll just call this steel fabrication, I guess. We'll call that for now. We'll save it to the my computer. Oops, sorry. We'll save it to desktop. Okay. So we'll create a new group, and we'll call it, or we call it steel cut, steel, I guess. Okay. And then we'll add some parameters to this. So stuff that we would need for fabrication. So probably cut length. So we'll make a parameter for that. So we want it to be seen by all disciplines, and it's a length. So this is pretty important here. When you're creating this shared parameter, really pay attention to this. If you forget to change this to the actual parameter that it is, you can't change it later. So just be very wary of that. So we'll create something else. We'll call it, I don't know, let's call it, make one part name. And we'll make this one text, just so you can see the difference. And we'll hit OK. So now we have this group of parameters here. So we'll hit OK again. So now cut length is brought into our project. And now this is where you actually have to kind of think about how you're going to use this parameter. So it's obviously not going to be a type because we want the length of the stud to flex. So we make it an instance. And then we also want this to be a reporting parameter. So if you've never used reporting parameters, really all it means is exactly what's in these brackets can be used to extract values from a geometric condition. So it's not used for anything other than pulling out information for scheduling. So we're going to need to check this as well. And this going under dimensions is totally fine. So now we have this item here, and it's 0 inches because it's not associated to anything. So we'll change that in a minute. But first, we're going to add another shared parameter, select, and we're going to make one called part name. And this one will be a type parameter because this one's going to be based on the actual item or stud. So we're actually going to find, there should be identity data here. So we're going to put it under identity data. We'll call it OK. So when we actually go to schedule, we're going to want to schedule by something, the actual, maybe the actual member type. So we'll make this 6 inch by 1 5/8. Gauge stud. And just for the sake of it, let's make the description like steel stud or something. Okay, so there's 2 ways we can do this. So we're going to just hit OK for now. There's 2 ways we can do this one. So we can actually go to the front and we can create a dimension from this reference plane to this reference plane, and we can actually give it this parameter name because that's really all it is. It's just a representation. So we can do it this way, where I can send the length this way, or if this is easier for you, you can actually just not even put a length in here and then just do a calculation of the length minus the cut back times 2. It's up to you. I personally like to use the dimension so I can see exactly where the cut length is being taken from. But if you want to do it the other way, that's up to you. So now we have a true length that we can actually use when we schedule, and we have a part name that we can use. So I'd say that's probably the extent of the shared parameters you would actually need for this item. Other stuff that you could maybe do is you could do maybe like an instance number, like maybe you needed a specific way of counting these, or like tag numbers, or if you knew that your 6 inch by 1 5/8 studs are all going to be stud type 01, maybe you wanted to create a specific type mark or something. It's pretty limitless. You can make it work any way you really want to. So we're just going to go through. I'm just going to add all this information in for these. So part name 5/8 of an inch by 1 inches. Where is this guy? There he is. So 2.5. Cool. Okay, so I think that kind of covers cut lengths. There really isn't, or shared parameters. I really don't think there's any much more we can go through right now that would apply. So I guess what we can do is we can finish off by actually doing the fine and medium type. So we'll start by just selecting the stud that we have right now, and we're going to go into the visibility settings here. So what these kind of do is, like, think of when you place a door in Revit, and you can, when you go from coarse, medium, fine, it changes the way that it's seen in the project. And you can do this with really anything in Revit. So because this is just squared out, we don't want to see this in fine view. So we're going to uncheck this, and we'll hit OK. So now this is only seen in coarse and medium view. So if we decide to, if we brought this into a project and we switched from medium to fine, it would disappear. So we're actually going to load this into a blank project that I have in open already. We're going to select here, place on work plane. We're going to scroll in because it's tiny, but we'll put it here. So we're in coarse right now. So we'll go to medium. It's fine. We'll go to fine. See, it disappears. Medium. Right? Okay. So what we're going to do is we're going to go into our reference level. Unfortunately, you can't hide this. It's always in view. It's kind of a silly thing with these generic models. It's probably just so you don't lose any of your geometry, but we're going to have to create another extrusion here. So we're going to do a box around. Actually, this is something you have to be careful of because we don't want to lock to the geometry. We want to lock to the reference plane. So I'm going to go to the outside here. So we'll align to here, here, here. Cool. We'll do a slice here. We'll offset. So basically the same process we did last time. Okay, so we got all our geometry locked. Ooh, the next step is, where's the fillet tool? That's not it. I think usually I do it this way. No. Okay, we're gonna use the fillet tool. So go here and here. So we want to make sure that we lock this tangent here, these two little tangent lines. If you don't lock them, you'll have issues. Stuff will just fly everywhere. So we'll make this 1 millimeter. And we'll do the same thing again. I'm actually just going to fillet these and then I'll come back and change the dimensions after. Actually, I think this is actually supposed to be less than that. Damn it. We're just going to leave it at 1 millimeter for now. We'll fix it later. More normal, actually. Anyways, just gonna make sure these are all locked. Okay, cool. And then the last thing we're gonna do is create the gauge. And we're also going to give this the same material. The front view. Drag this up. Now I think the last thing we need to do here is just change this so that way it doesn't show up in coarse and medium, because otherwise we'll get geometry overlaying in that view. So we'll hit OK, and then we'll load this back into project. So this is going back into our other project. We want to overwrite values. So now what we should get is rounded corners and fine view. So just to make sure that this worked, we're going to create similar, place it on the work plane. We're going to select this and we're going to create our two types. So we're going to have our 3 5/8. We're going to have our 2.5. So it looks like they all worked. That's good. Sometimes it takes some finicky working around to try and get them to work properly, but usually they work the first time. Okay, sweet. So if we go to, we're going to create an elevation view here, just to make sure that these all work, the elevations all work for these. So kind of the nice thing with these is, you know, they stretch. That's one thing that's really nice about them. We placed it on the level 4, so it'll actually stay there. And we can change, usually you can change the reference level right here. So we can make it, you know, go right to the roof if we really wanted it to. For some reason it doesn't like that. Anyways, if it doesn't work, you can always just drag and lock it. And it'll give you your offset as well, which is nice. So if I decide to create, go here and create similar. Actually, we'd probably have to go create similar, place on work plane, then you have to select one. So pick level 2. Okay, and it'll ask you to pick a view, so place it in space, I guess. It's kind of silly. I don't understand why I did that. Anyways, you can see there, it attached to level 2 and then it went up 1 level. If you wanted to detach it, bring it to here. It also attaches to work planes as well. So if we went to level 1, maybe we wanted to draw a stud this way instead. Go to architecture, reference plane. Name it, so we'll name it test. Then we'll what are we gonna do here? We'll draw a create similar, place on work plane. In here. There's our reference plane test. I'll ask you to move. So we'll pick north. So you can see it actually rotated the orientation of this stud. And you can rotate it. So if, let's say you were doing joist work, you needed to use a bunch of studs. Not that you would, but if you wanted to use, if you were doing something for, let's see, let's say you were doing wood joists, it'd be the same thing, except, you know, the geometry would be simpler. I think that's kind of a good place to end this video. So, as you can see, that creating your own stud types is actually very beneficial. And you can basically use the same thing when creating track types. So a track type is the same thing as this stud type. That's something that I'm thinking about doing another video about, because then I can show you how these actual shared parameters work with each other. Because that cut length parameter that we created, we can use again in that track, and then we can load them back in as well into this project here. And then we can go through and I can explain how to actually pull this information out with the schedules. So I hope you enjoyed this video, and maybe I'll see you soon.